Hello learners, today we are going to discuss about some of the important aspects of the chemical hazards which comes under the MEV 002, that is environmental and occupational hazards. Today's chemical hazards we are going to discuss about reactive material. So before going into the details of this topic, we have to recapitulate what we have learnt previously. So in the previous session we have learnt about the corrosive hazards. So pure metals and then their alloys also interact gradually with the elements of the corrosive medium to form stable compounds, and also the resulting metal surfaces is normally we can call it as a corroded. If we will see some of the rust. In the corrosion reaction, that is also an anode and then electrode, in between that the electrons will flow. So it is an uniform process, and also it will become a very intensely localized and also characterized by the pitting method. So the mechanisms that can be directly considered are oxidation. For example, when a metal is heated in an oxidizing environment or electrochemical environment, so galvanic corrosion may evolve sufficiently because of the evolution of the hydrogen. So evolution of hydrogen causes a hazard due to the formation of the flammable atmosphere with air in the equipment or piping, and sometimes it may happen also the building up of the internal pressure within a weakening container, and the production of atomic hydrogen as a species, or otherwise it is a byproduct, and also this may penetrate metal into produce the blistering effect, and then sometimes it is also known as the embrittlement. So the consumption of oxygen due to atmospheric corrosion, which is in a sealed metal tanks, that may cause a hazard because of the oxygen deficiency that affects the person, those who are present there. And then stress, sometimes stress may also develop, which is also the resulting from the increased volume of the corrosion products like rust formation, that involves mostly 7-fold increase in the volume. So before this recapitulation, and then now we have to go for the today's topic. So all chemical reactions which involves energy changes, because there is a combination of active energy as well as the reaction energy. But in some cases the heat of a reaction is absorbed into the products, and also the reaction that cools, that means endothermic reaction. And sometimes in most of the reactions, the reaction takes place after the release of the energy as a heat. So if heat is released, we can consider as a exothermic reaction. If heat is released for the benefit of the reaction or for the cooling of the elements, then we can call it as an endothermic reaction. And sometimes the energy is released in the form of light, in the form of sound also in some reactions. So when the heat is liberated or absorbed, that cannot be accommodated by the surrounding environment. So what will happen? The resulting into a hazard. So that means it may cause the damage of the materials. So this may also arise because the amount of energy, that means the energy which is involved, we can consider, and then we can learn from the thermodynamics of that particular product, or the rate of energy released due to the speed of reaction. So whenever there is a speed of reaction calculation, then we have to consider that is a reaction kinetics. So that is excessive. So that means the thermal stability of any system, and then to control the extent and rate of heat that releases to minimize the risk from the energetic hazards. So reactive chemical hazards, they may normally arises from the inherent properties of the chemicals which are handled, and also they may be sometimes used or disposed of, and then also from their mixtures, that is the additional mixtures of the combination of two or more, or sometimes in the processing way. So these type of chemical reactions will occur, and also they are so reactive in nature. So here we have to understand that what is meant by a hazard. We have already learnt, but we have to understand again. A hazard may arise when a chemical or with a chemical reaction, because of its tendency to decompose immediately, spontaneously, or to react violently on contact with each other, and also with some other common chemicals. But in sometimes extreme caution is necessary with mixed chemical systems are working. That means they are thermodynamically unstable and also exhibit considerable kinetic stability. So there is a kinetic barrier to stability, that means it may be overcome if traces of catalysts are present. So here the third important characteristic feature came into the picture, that is a catalyst. So that means the resultant reaction is a violent reaction. So that means catalyst is also most important to become a reaction, a more reactive. So the most common catalyst that are derived from the metals, and also sometimes they are from the metallic compounds, and also they are unpredictable behavior of many reactions which are normally comes from the unwitting presence of the impurities. So some other catalysts like acids, bases, and also organic free radical precursors, these are also acts as a catalyst. So any system, it will be treated with a care that is thermodynamically unstable, or sometimes it may contain a catalyst or impurities which could serve as a catalyst. So some chemicals are water sensitive. That means whenever they will come in contact with water, they can generate flammable or toxic gases, and also sometimes undergo a vigorous reaction. So such reactions can cause overpressure in sealed equipment or in pipes or the pipe work. For example, acetyl chloride is there. It reacts with water, then the reaction mixture is toxic in nature. If we will consider acetyl bromide, that also reacts with water and the reaction mixture is very toxic in nature, and also the reaction is very vigorous. And we know that sulfuric acid, that is a fuming sulfuric acid, which normally we can call it as an oleum, that also vigorous and toxic in nature. And acetyl chloride, another chemical, that is also colorless, fuming, and also corrosive liquid. And flash point 4 degrees centigrade, when heated it emits phosgene, and it decomposes violently with water to produce heat and toxic fumes of hydrogen chloride. And another chemical we will see that is a benzoyl chloride. It is also colorless but fuming but corrosive liquid with a strong odor, and it is highly combustible in nature. Its flash point is 72 degrees centigrade, and then fumes it will come and then generates the phosgene gas. When use of water must be considered carefully heated. And it reacts strongly with water or the water vapor also, producing heat, and also it is toxic in nature and highly corrosive in nature. So whenever this type of chemicals we are working, so they are so reactive in the reaction mixture, so precautions have to be taken care. So what type of precautions we have to taken care of for the whenever we are working with this one? So there should be a provision of adequate training, and instruction and supervision is highly required to the people, those who are working with this type of chemical reactions. And the prohibition on unauthorized mixing, that means not all chemicals can mix with each other. So that means cleaning agents or waste, so they have to correct labels should be there, and there should be a segregation in storage to avoid the accidental mixing, and also dispose of waste and the empty containers by the different routes we have to follow. And specific precautions also again is the compounds which are having the inherent hazards which can cause the hazardous reactions, and for each individual chemical. And also some of the safe handling methods we have to follow, that means storage and use in such a way that the accidental ingestion of water or contact with the water is to be avoided. That means roofs of that storage area should be regularly maintained to minimize the leaks. So that means we have to check whether leaks are there or not. And also provide a covered storage, that means off the ground and then away from the sprinkler systems, and safety shafts, and then overhead water lines are that is to condensate the lines, and also keep away from the water taps or sinks whenever there is a vigorous reaction with the acids. and also store under the chemically inert medium when appropriate. That means stock should be checked regularly to ensure that an adequate level of inert medium is maintained or not. And also segregation is also most important one. That means segregation from other flammable materials like solvents and combustibles, and also use of appropriate eye face or protection, that is a shielding, and also we have to use the gloves for the hand protection. Now we will see that some of the reactive chemicals which are acts as an oxidizing agents. Even though not normally spontaneously they are flammable, but frequently represent a source of oxygen that can support the combustion. So they will react readily in contact with reducing agents. So an oxidizing agent will definitely accelerate the rate of burning of a combustible material or combustible chemical. So in finely divided state, that means very finely divided powder like mixtures that make react explosively because the surface area is high. For example, aluminum nitrate is there, ammonium persulfate. Another example, barium nitrate or calcium nitrate or peroxides. They will increase the burning rate of combustible materials. And also they will form the highly flammable or explosive mixtures with finely divided combustible materials. And also hazards which are arising from the oxidation of organic compounds are greater when the reactants are volatile in nature, and then that means they can easily converted into vapor state, or sometimes they may present as a dust or just like an aerosol, we can say that. So liquid oxygen and also some other concentrated acids like nitric acid, sulfuric acid or perchloric acid and chromic acids, they are strong oxidizing agents. So the use of perchloric acid or perchlorates, that means the chlorinated compounds, they have resulted into the numerous explosions. So their use should be avoided whenever there is a possibility. So now we will come to the explosive chemicals. So flammable chemicals we have seen, and the oxidizing chemicals we have seen, those who are having the very reactive reactions, they are very reactive sometimes at the normal temperature. And explosive chemicals are they normally involve in the flammable gases. They contains the vapors and also sometimes dust, and what we have already discussed. In addition to that, certain chemicals may explode as a result of violent self-reaction. So this is most important characteristic features of some of the chemicals. So or otherwise, that means it can undergo a self-reaction, or sometimes it will decompose when subjected to mechanical shock or friction or heat, light energy or catalytic contaminants. So that means we have to store these under the refrigerator conditions. And then high explosive sometimes will happen that detonate to produce shock waves. For example, materials which are easily detonated by the mechanical or electrical stimuli, they are known as the primary explosives. That means a small friction is sufficient enough to make them to explode. And then some compounds, they require an impinging shock wave to initiate them, or normally call them as a secondary explosive chemicals. So pyrotechnics, they can burn to produce heat or smoke or light, sometimes noise. And some types of compounds are there, they are normally call it as propellants. They can also easily burn to produce heat and also gas as a means of pressurizing pistons, or to start engines, or to propel the projectiles and then rockets. And now we will see some of the chemicals, that is chemical reaction hazards. That means some type of reactions, they have specific characteristic features. Reaction in gas or liquid, normally we can call it as a neat reaction, or in solution or in suspension, or it can be in the form of emulsion or in the form of solid phase. Some reactions are catalytic in nature. That means only if catalyst is present, then only the reaction will move forward. are sometimes non-catalytic in nature. That means there is no requirement of the catalyst. And exothermic reactions are there, endothermic reactions are there, or otherwise sometimes negligible heat loss or gain in some reactions. And in some reactions they are reversible reactions and some are not. And first and second order are the complex kinetics. So these type of reactions which whenever we will perform, those reactors may be operated batch wise, or otherwise if it is continuously, if we can keep this type of reactions continuously, like we have to use in the tubular or tubes in shells with or without internal catalyst beds. And then also sometimes continuous stirring tank or the fluidized bed reactors are there. And continuous reactors generally offer the advantage of low material inventory and also reduce the variation of operating parameters. And recycle of reactants products, and also sometimes we need to dilute these reactions with the diluent, and it is frequently used with the continuous reactors, possibly in conjunction with the external heat exchanger. And adequate heat removal facilities are also generally important when controlling the progress of exothermic chemical reaction. And gas cleaning also most important measure we have to take by the filtration, and then demisting and electrostatic precipitation and wet collection of the particulate matter, and by using the cyclonic separation. So dependent on the chemicals which are in process, each of these may introduce a range of hazards. For example, chemicals, flammables or mechanical. So these must be checked in each and every case. So to avoid runaway conditions or an explosion, control may involve, that means the use of dilute solutions, use of emulsions or suspensions, and feeding one reactant at a time with a controlled rate depending upon the reactant's temperature. That means close monitoring is required. Sometimes refluxing, in that process also refluxing of solvent from a condenser, and also imposing a limit on reactor size to ensure adequate heat transfer area per unit volume, and careful selection of reactant and coolant temperature, that is also most important. That means we have to find out before starting the reaction. And the provision of efficient agitation, that is a mitigation of the runaway reaction, that involves emergency cooling is required, and then dumping of reactants into an empty vessel or the containers which have the compatible quenching liquid. So these things we have to monitor. And the precautions with any particular explosive is mainly dependent on the hazard. So if we will consider a case study like United Kingdom, they have classified all the explosives into some other chemical categories. They have categorized these reactive chemicals into category 1 as a gunpowder. So we know that gunpowder is also known as the black powder or smokeless powder in the earliest known chemical explosive. It consists of the mixture of sulfur, charcoal and also potassium nitrate. So potassium nitrate is a saltpeter, normal way we will call it as. The sulfur and charcoal, both of them acts as a fuels, while the saltpeter is an oxidizing agent. So that is a reactive chemical. And nitrate mixtures are there, nitro compounds and chlorate mixtures and fulminate mixtures, ammunitions and also fireworks. So that means they have categorized all the reactive materials or the reactive chemicals into 7 categories. And then we will see that some of the characteristics of some different types of reactions. For example, first we will consider the oxidation. So in that oxidation reaction, starting with the feedstock, that is generally hydrocarbons, the hazard of fire or explosion arises from the contact of flammable material with oxygen. So reactions are highly exothermic in nature, and the equilibrium, that is a reaction equilibrium, that favors complete of the reaction. And if we will see the polymerization reaction, in this reaction is also an exothermic reaction unless carefully controlled, and it can also cause the runaway and create a thermal explosion, or sometimes vessel over pressurization for the common monomers which are used in the polymerization. And certain processes also there that require polymerization of feedstocks at high pressure with associated hazards, mainly that vinyl monomers, that is a vinyl chloride or acrylonitrile. They definitely pose a chronic toxicity hazard for the basic precautions. So the utmost precautions should be required while using this type of chemicals. And then halogenations. So that means these are commercially important halogens are chlorine and bromine, fluorine, iodine. So all are highly toxic reactions and then highly toxic in nature, and they are highly exothermic reaction and also chain reactions that can occur because these reactions normally they will start and initiate with the formation of the free radicals. So they definitely result in detonation process. If we will consider the hydro processes, so hydrogen is chemically stable, and we know that they are relatively unreactive at ordinary temperature, that means room temperature. But most reaction processes utilizing it require a catalyst. So there is a criteria, that means above 500 degrees centigrade, if it reacts readily with the oxygen and confined to the flammable mixtures, explode violently if ignited. So main hazards are associated with this reaction are fire explosion and also metallurgical problems arising from the hydrogen whenever there is an attack. And if you will consider the nitration reaction, so in the nitration reaction the possible hazards are arising from the strong oxidizing nature of the nitrating agents. For example, normal nitrating mixtures are the mixture of nitric and sulfuric acids, and from the explosive characteristics of some end products. So the reactions and the side reactions which are involving oxidation are highly exothermic in nature, and also they will occur very rapidly. So sensitive temperature control is essential feature to avoid the runaway type of reactions. Next we will consider the alkylation reaction. So because of this alkylation reaction, hazards may be the alkylating agents, that means dimethyl sulfate, that is also one of the suspected human carcinogen, and hydrogen fluoride. They are highly toxic in nature and also it is an irritating gas. So the thermal alkylation process that requires high temperatures and pressures with associated with the problems. And some reactions they will also have the high pressure reactions. So that means high inventories of the stored pressure, like pressurized reactions or associated plants, that can result in the catastrophic failure of the pressure shell. And some of the measures we can see that are the, otherwise we can say that chemical engineering operations. That means many chemical engineering unit operations, they may be linked together in a chemical processing. So most common are the fluid mechanics, that means pumping of liquids and compression of gases, mixing, that is the solids, liquids, gases, possibly in the multi-phase reactions, and also atomization, dispersion. So in these type we have to understand the heat transfer, how that heat will be transferred. So the convective heat exchange and also the natural or sometimes forced radiant heat transfer, like in furnaces the evaporation will happen, and also in evaporators condensation, in shell and tube heat exchanges, and also heat transfer to boiling liquids in vaporization medium, boilers or reboilers. And what type of hazard rating of chemical reactions we can expect? That means the reaction between carboxylic acid and diazomethane, for example, they are highly flammable and also develops high pressure instantly, and also they are highly toxic in nature. And one more example I would like to give, that the reaction between acetylene and carboxylic acid vinyl ester. So they also highly flammable and also develops high pressure instantly. So they are highly toxic in nature. And most common reaction, that is a Schmidt reaction. It is a reaction between the carbonyl compounds and hydroxoic acid in the presence of concentrated sulfuric acid. So this reaction is also flammable, perhaps explosive mixtures from the reaction. And in halogenation reactions, mostly we will consider with the chlorine as well as bromine. So they are also flammable and also generates toxic substances. So many processes that require equipment which is designed to rigid specifications together with automatic control and also safety devices. So consideration should be given to the control and limitation of the effects of equipment malfunction, and some of the malfunctions in generally we will observe is the stirrer failure or the whether it is a mechanical stirrer or the electrical stirrer, and also sometimes attainment of abnormal reaction conditions like over pressure, over temperature, and segregation of the reactants, excessive reaction rate, or the initiation of side reactions, power failure sometimes, and pumps, and errors in valves, and failure to actuate the agitation at the proper time. So these are the some of the failures of the instrument air or electricity, and failure for the relief devices like pressure relief valves are sometimes rupturing in discs, and addition of wrong materials, or sometimes it is a wrong quantities also, and failure to add materials like short stop or the inhibitor, and spillage of material. So there are so many reaction processes they occurred in this one. Sometimes it is also most important there is a restricted or the blocked vent, and restricted material which flows in and out, and leakage of the materials out like due to the gasket failure or air block. So these are the normal malfunctions of the equipment. So normally engineering controls are highly required. Dear learner, so far we have studied about how the chemical are so reactive in a reaction mixture. So we have studied, and then what are the adverse effects of that reaction mixture of that particular reactions. So I would like to conclude that of course chemicals are present everywhere in air, carbohydrates, enzymes, lipids, minerals, proteins, and water, and then simple wood. But naturally occurring chemicals are also supplemented by the man-made substances. There are more than 1 lakh chemicals are present in use right now, and also some more maybe it is a 500 to 1000 may be added each year. So their properties have been harnessed to enhance the quality of life, like cosmetics, detergents, energy fuels, explosives, food additives, pesticides, pharmaceuticals. So chemicals are found in virtually all workplaces. Besides the benefits, they also pose dangers to man and the environment. So the hazards of chemicals, that is started from the inherent flammable, explosive, and some are radioactive in nature. And the effect of exposure on a personal may be acute, or sometimes it is a chronic also. So we have to be very careful before starting any of the reactions. And alternatively, prolonged or the intermittent exposure may result in an occupational disease, or sometimes it is a poisoning. So I think you must have benefited with this session, and we will come up with some other topics in the environmental and occupational hazards. Thank you.